You are a ghost. If you are a plant living in the coastal regions of the United States, which is your cause of death? A. Dryness. B. Seawater intrusion. Or C. Pest and disease. The answer is B. Seawater intrusion. But do you know why seawater causes plants like you to die? Let's jump back into our memory to find out the truth. Originally, I lived in a freshwater wetland, surrounded by neighbors like the water tupelo, bald cypress and swamp black gum. Life was good, but as sea levels rise, saltwater begins to push inland, invading our once freshwater home. The salt in the seawater becomes our worst enemy. Prevents me from absorbing fresh water, leading to dehydration. My leaves and branches start falling. And eventually, I fell with my friends. This transformation of wetland forests into dead trees is called a ghost forest. What remains are salt-tolerant plants known as salt marshes. This isn't just a hypothetical scenario. Ghost forests are a reality in low-lying coastal areas, especially in the southeastern United States, such as along the South Carolina coast. Rising sea levels are reshaping ecosystems, placing freshwater wetlands with salt marshes. But the story doesn't end with changes in vegetation. There's much more happening both above and below ground. To understand the full impact of seawater intrusion on coastal ecosystems, scientists at CUHK collaborated with scientists in the USA to conduct a research study examining the changes from healthy forest wetlands to ghost forests and salt marshes. Environmental samples, including air, water, and sediments, were collected once a month for 2 years for detailed chemical and microbial analyses. During the analysis of water samples, scientists observed a gradual increase in salt content among freshwater wetlands, ghost forests, and salt marshes. For reference, seawater is about 35 grams per liter, while the salt content in freshwater wetlands rises from 0.5 grams per liter to 18 grams per liter in salt marshes. That might not sound like much, but consider this. It's like adding 2 tablespoons of salt to your drinking water every day. That's enough to kill even the strongest trees. Charles Darwin once said, "Survival of the fittest." This holds true not only for the trees, but also for the microbes living in these ecosystems. As salt levels rise, the microbial community changes dramatically. Salt-tolerant microbes thrive, adapting to the higher salinity, while the original freshwater microbes decline. This shift in microbial activity alters the entire ecosystem and its processes. But here's something even more surprising. Ghost forests don't just affect vegetation or microbes. They also change greenhouse gas emissions. Besides the well-known greenhouse gases like carbon dioxide, another type of greenhouse gas known as halocarbon can be generated in ghost forests and salt marshes. Examples are chloroform and methyl chloride. To better understand what they are, consider common greenhouse gases. Methane as an example. Methane is formed by 1 carbon atom and 4 hydrogen atoms. When 1 hydrogen atom is replaced by 1 chlorine atom, methyl chloride is formed. 3 hydrogen atoms are replaced by chlorine atoms. Chloroform is formed. That's the compound shown in the movie that can cause dizziness and fainting. Halocarbons are problematic because they can release chlorine radicals, which are the villains responsible for ozone destruction. But why do ghost forests produce halocarbons? When leaves and branches fall in these high salinity environments, they create the perfect conditions for chemical reactions. These reactions involve metal ions, organic matter, and hydrogen peroxide, which generate halocarbon. When the halocarbons rise into the atmosphere, they react with sunlight and generate Cl radicals, which contribute to ozone depletion. In summary, seawater intrusion creates a domino effect. First, saltwater kills freshwater vegetation, forming ghost forests. Second, saltwater shifts microbial communities to salt-tolerant species. Third, because of the shifts in vegetation and microbial communities, ecosystem function changes, increasing halocarbon emissions. Fourth, halocarbons, another type of greenhouse gas, pose a risk to the ozone layer. If you're curious to learn more about this fascinating and critical topic, check out our video based on Professor Alex Chow's research and dive into the related scientific paper.